Hello, everybody. Again, thank you for joining us today. My name is Vadim, and I will be your guide in this Data Wrangler workshop. So the goal of this session is for you to get familiar with Data Wrangler's functionality, interface, and understand how it operates within the overall SageMaker ecosystem. As we mentioned earlier today, this will be a predominantly demonstration type of session. And I'm going to use a sample data set, the hotels data set, which you have links to, and guide you from start to finish on how to bring that data set into Data Wrangler, perform few common data exploratory functions, apply some transformations, and we will then take a look at some of the options that you have available in Data Wrangler to export the workflow that we're going to create today so that you could later automate it and productionalize it and run it in a repeatable manner. So before we jump into the environment itself, into the demo, let's take a step back a little bit and maybe talk a little bit about what is Data Wrangler. And in fact, I'll even take another step back and kind of show you where Data Wrangler fits into the Amazon SageMaker framework. And for those of you who are not aware or are not familiar with Amazon SageMaker, this is AWS offering which allows data scientists to easily prepare, build, train, tune, and deploy and subsequently manage machine learning models. And as you can see, Data Wrangler is right here in the prepare stage of Amazon SageMaker because it's a tool for data wrangling, as the name implies. We will predominantly spend our time here in the Data Wrangler, but you will notice as we go through the workshop that it integrates quite well with a lot of other features of SageMaker. As a matter of fact, by the end of this lab, you will also see how Data Wrangler actually kicks off a SageMaker processing job to actually do the data transformations. You will notice that there are features which allow you to not only export data out of Data Wrangler into a storage system, but also it can export data into SageMaker feature store. And because we are dealing with raw data, sometimes the preparation step of data science lifecycle also is a good spot for running some basic checks on quality of your data. And SageMaker Clarify allows you to analyze the data set that you have at hand and maybe look for bias or establish certain constraints that that apply to your data, which later on could be used in production environments during model monitoring stages. Because if you trained your model on data with certain types of distributions, with certain types of feature types, you can monitor for that data quality during the model deployment phase and see if the inference requests that you're getting have the same distribution and the feature types remain the same. So those are some of the things that we'll touch on. But again, our main goal, obviously, today is to spend as much time and go as deep as possible on SageMaker Data Wrangler and understand how it works. So let's go ahead and hop into the actual environment. Those of you who chose to follow along this webinar, you probably have a link to the event engine. You should have the link to event engine, and you should have authenticated by now. And hopefully you are at the screen that shows this team dashboard. you already have the link to the webinar, to this lab guide. So you can also choose to just watch me walking through the steps of the guide, and then you'll have access to this environment after the webinar as well. So you can then step through the same steps, go through the same steps at your own pace. But you're also welcome to follow along as I'm going to go through this lab. So we are at the team dashboard. Let's go ahead and click on the AWS console. This brings up a pop-up in which we again choose Open Console. And this launches AWS console, which you may have slightly different look, but in general, it should be somewhat similar to this. On the left-hand side, you'll see the recently visited services. Yours might be a little different. But what we're going to do here is at the top, in the upper left corner, in the search bar, we will type SageMaker. And out of the two SageMaker offerings, Studio and Canvas, we will pick Studio because Data Wrangler is part of SageMaker Studio. Once in the control panel, there is a SageMaker user pre-provisioned in this demo environment. I'm going to click Launch App, choose Studio, and that brings me into the actual SageMaker Studio. As you saw on the previous slide, Data Wrangler is one of the features of SageMaker Studio. There are a number of them, and Data Wrangler is one of them. But the way you use it, the way you access it, is by logging into the Studio UI first. So what you see on the screen right now is the Studio UI, SageMaker Studio UI. Let me make it a little bigger font. And on the left-hand side, there is a vertical menu with different options, and we are looking to go to the very last one, this little triangle. So I'm going to click on that. By default, it brings you to projects, but we're going to change that from projects to Data Wrangler, and that will initialize, oh, not quite. So the Data Wrangler, and one other thing we need to do is we're going to click New Flow button. That will actually begin the initialization process for the Data Wrangler. While it is, no, that was quick, it initializes quickly, but I wanted to kind of give you an idea of what's happening now behind the scenes in the Studio UI that we logged in. On this architectural diagram, we are here right now, and we just connected to SageMaker Studio. And in order to render Studio UI on our screens, a virtual machine was started. A T3 Medium virtual machine came up. This virtual machine is provisioned at no charge, no cost to you. So you don't have to pay for it. It's just there to render UI. It's not very powerful. There is no computations of any kind that we will run on it. But just so you know, that's what kind of drives the user interface of SageMaker Studio. And by selecting Data Wrangler in the Studio UI, right now we are here, another virtual machine was provisioned, which will actually power every interaction with Data Wrangler that we're going to perform now. As we start running various analysis, as we start creating different transformations, as we're going to bring in the data set into Data Wrangler, all of that will be taking place on this virtual machine. And this machine does have a cost associated with it. So be mindful of that. And as you completed your session with Data Wrangler, it is a good practice to shut it down, just so that resources are not wasted. Let me show you where you can actually see that. If I hop back to the Studio UI, one of the menu items here on the left-hand side is this round circle. If I come here, you'll notice that there is a Data Wrangler virtual machine that's running M5 16 CPUs, 64 gigs of RAM. And to power it down, you simply click this button here, switch it off, and it'll power down. Because it's a pre-provisioned lab environment, there is another machine that's running to power some of your Jupyter notebooks. In your environment, if you're starting Data Wrangler for the first time, the second virtual machine probably won't be around. So back to Data Wrangler. We are logged into its user interface. You can see that we are authoring a flow file. I'll talk a little bit about that later. It's currently called Untitled Flow. Let's go ahead and rename it by right-clicking on this tab and choosing Rename Data Flow. I'm going to call it Hotels because we'll be exploring hotels data set. And so I'm going to click Rename. The name will propagate in a few minutes to the left-hand side, so don't worry about that. And as you can see here on this diagram, the first step will be to import the data. Hopefully you have the data set downloaded. If not, it's a Kaggle data set that we will be using. If you want to kind of quickly search for it, you can start on Google and search Kaggle hotel booking demand. And it'll take you to this Kaggle website. And in the upper right corner, there is a download button to download the data set. It will ask you to create a Kaggle account. So it might take you a couple of minutes to get through the authentication. But once you do, it's a CSV file that you will download. And that's what we will be using for this workshop. So in order to import the data set, let's go ahead and click on that. You see there are a couple of options listed here, Amazon S3, Amazon Athena, and there is a couple of other sources that we can add, Redshift, Snowflake, Databricks. There isn't an option to just drag and drop an Excel file in here, a CSV file. So what we need to do is we need to pre-stage our data in the storage layer with which Data Wrangler operates. So in this case, we will be using S3. And just to kind of put it into context, this again is it's another depiction of SageMaker pipeline. You saw on the previous slide how we talked that SageMaker has pre-processing functionality, then model training functionality, then model deployment, and then model monitoring. So this is an in-depth view into all of that, kind of a little more in-depth. You'll see how raw data comes into SageMaker as potentially unlabeled data. There is a tool for labeling that data. If you are building supervised machine learning algorithm, you would want it labeled. And you can see how Ground Truth brings in unlabeled data from this storage layer, and then labeled data comes back into it. This is where we are right now in the Data Wrangler, and we are authoring a pre-processing job. And you'll see how pre-processing, again, will take data from the storage layer, does something with it, puts it back. You'll have the option later on to put that ingested data into feature store. Any training jobs, subsequent training jobs that you might run will also ingest data from that same storage layer. The resulting models will go back to that storage layer. Those models can also be checked into model registry. And finally, inference is done by pulling in the models from that same storage layer. So you can see how the entire pipelines, entire SageMaker data science workflow is centered around the storage layer. And so the storage layer is called S3, simple storage layer, and we will be relying on it quite a bit, and you'll see it referenced in Data Wrangler, as well as in all the other features and functions of SageMaker that we will be touching. let's go back to here. And obviously, I downloaded the CSV file, the hotels data set from Kaggle. It's on my local drive right now. So first thing I need to do is actually upload it to S3 storage bucket. For that, I'm going to go back to the prior tab that which we used to open AWS Console. And I'm going to click it one more time, Open Console. It'll open another copy of AWS Console for me. And this time, instead of going to SageMaker, I'm going to go to our simple storage service, S3, here at the top in the search bar. I'm typing in S3, clicking on that. And that brings me to my simple storage service dashboard. There are two storage buckets that have been pre-created for me. In S3, buckets are kind of similar like folders. You can think of them as folders. So I will use the SageMaker US East 1 bucket, not the Studio, but US East 1 bucket. I will go in there, and I will upload my data set into this bucket. So I'll click Upload, Add Files, and one of them is Hotel Bookings. Open, and click Upload. So this actually takes the file from my local laptop and ships it into the S3 storage layer so that it is now accessible to all SageMaker features. You can see it's right here. Let's click on it. And out of curiosity, I want to see how many records are there. One of the functions in S3 is you can actually run queries against flat files. So I'm going to go and select query with S3 select. It's a CSV file, comma delimited. And I'm going to do select count, get rid of the limit, run the query. And query results, 120,000 rows roughly. So that CSV file has 120,000 records. So that's good to know. Let's make a mental note of that. And I'm going to go back to the Jupyter Lab tab. Now I'm ready to bring that file into Data Wrangler. So I'm going to select Amazon S3, navigate to this SageMaker US East 1 bucket. Yours will be called something very similar, but the suffix will be different. The account number for each of you will vary. I'll go in there, and here's my hotel bookings data set. So I'll just click on it once to bring in details about it. And I will also go ahead and collapse this pane on the left-hand side by clicking on the triangle, so it toggles off to get more real estate here to examine my data. So we can see that the size of the file is 16 megabytes. It is a CSV file, comma separated. You can inspect the data inside the file right here. You can see all the columns. We know now it's 120,000 records, which brings up a point here. We are now, you can notice here in the upper right corner, and as you remember from the diagram, architectural diagram, we are running Data Wrangler on a single virtual machine. It is a large one, 16 CPUs, 64 gigs of RAM. We are going to be crunching through this data set, which is not too big of a data set. We can totally ingest it completely into the memory of this virtual machine. But some of you, or many of you at some point, or even right away, are most likely to be dealing with data sets that are much larger and most likely will not fit into the memory of a single virtual machine. So what do we do about that? Well, for starters, the idea of Data Wrangler is creation of pre-processing jobs and recipes. In fact, let me come back to my slides here. And this would be a good time to describe the Data Wrangler paradigm.
So again, on this architectural diagram, we are here in the data Wrangler. We brought in our data set from other sources. We imported it into, we uploaded it into S3, and we are about to bring it into a data Wrangler. But let's pretend that our data set is too big and will not fit into the memory of data Wrangler. So by default, actually, data Wrangler assumes that, and it offers you to sample your data. And the idea is that everything that we are going to do in data Wrangler for this point on, we are going to be defining transformations one after another, manipulating with fields, dropping columns, adding new things, feature engineering. And so this list of transformations will be, in the end, exported as a recipe. So this .flow file, which, as you remember, we renamed from whatever it was, undefined to hotels. This will be our recipe file. It will actually contain the exact steps that need to be applied to data. The second artifact, the other artifact that data Wrangler will produce at the end of our session is a Jupyter notebook with orchestration code. So transformation recipes here, orchestration code here. This orchestration code will have all the logic necessary to start and run a processing job. This processing job will take the transformation recipe, and then it will run against the entire full data set. So even though we sampled the data to create our recipe, the actual processing job that we will run will do so against the entire full data set. And these processing jobs are powered by Spark clusters, and they are highly scalable and can do massive parallel operations. So there could be multiple instances of them running, and you are actually in control of that. And in the end, the transformed data set will be stored back into S3. At the end of the lab, we will also explore some of the options of how these processing jobs can be scheduled. There is a number of options there. But for now, just so you know, this is why we are seeing the sampling choice on the right-hand side in our Studio UI right here. It offers us to sample data. First 50,000 records. We know we have roughly, 120 or 130, but we'll pretend that our data set is much bigger. Some of the other options here for sampling is random. First K, by the way, means that it's just going to take first so many records, 1, 2, 3, 4, 5 sequentially. You can shuffle them, kind of get random, or you can do stratified selection. And you'll notice that if you choose stratified, it asks you which column is of importance to you, because what we are most likely we are importing this data to build either a regression or classification model. And if it is a classifier, and in fact that's what we're building today, a classifier, one of the columns will be our target column. So we will be predicting whether or not a hotel reservation is likely to be canceled. And so based on our target column, Data Wrangler will attempt to select records from this data set in such a way that all classes are represented more or less evenly. So the data set is as close to being balanced as possible. And depending on your exploratory data analysis goals, depending on your knowledge of data set, this may or may not be a valuable option for you. So today we are going to go with just first K, first 5,000 records. Balanced data set is too easy, right? So let's do that. So we dialed in our selections, and go ahead and click import. And that will ingest first 50,000 records from that S3 file into Data Wrangler. And on the right-hand side, you can see our first 2 transformations. As I mentioned, the idea of Data Wrangler is dial in all the transformations and save them as a pipeline. And these are our first 2. The first one is actually choosing the data source, where the data comes from. This is convenient, by the way, because that means you can reuse this recipe later on, even maybe outside of Data Wrangler, and just swap out this step with something else. And number 2, Data Wrangler, step number 2, Data Wrangler automatically identified the types of columns in our data set. And here we have a choice to change that. If we see that some of the features are not the type we want them to be, this is our chance to change that. So we have our 2 transformations. Before we proceed any further, let's talk a little bit about the, well, actually, no. We'll take a closer look at the data set in a little bit. I'm going to go back to the home screen of Data Wrangler, which I will do by clicking here on Data Flow, little breadcrumb in the upper left corner. And you can see already that Data Wrangler is automatically building a direct acyclic graph of your data flow. You'll see how we started with hotel bookings.csv, and our first transformation was applied, which were the data types, column types. So the way you navigate Data Wrangler from this point on is by adding additional steps here, by clicking on this plus sign. And you can see there are, these are the steps available to you. Transforms, various types of analysis. You can actually kick off a model training from here, which will use autopilot. You can sync your data from the memory of this instance directly either back into S3 or into SageMaker feature store. Or you can produce those 2 artifacts that I mentioned earlier, the transformation recipe and orchestration code, for variety of pipelines, variety of jobs that you can then integrate with your other maybe higher level orchestration layer, which will rely on Data Wrangler to produce data which will go elsewhere. Again, we'll review all that in a little bit. But for now, we'll start with creating our first analysis. Right now, it's you can find it under analysis here, but it's been also brought out to the main menu, because this is usually the first step that we see data scientists begin data exploration in their workflows. So let's click on that, and you'll notice that we ended up in analysis part of the Data Wrangler. The analysis type, there are multiple types, but the one for data quality and insights was automatically selected for us. The only thing that we need to tell it is what kind of problem are we solving? Is it regression or classification? And what is our target column of interest? What it is that we will be predicting? We will be predicting the cancellation likelihood, and it's going to be a classifier. So I'm going to go ahead and click Create. And while the report is being generated, let's take a look at the data set itself. In the walkthrough guide that you guys have access to, under Getting Started section, you'll see that the data set is described here. Basically, this data set is a snapshot of data. It's a snapshot in time, was taken from, I don't know, a reservation system of some sort, which lists variety of hotels, current status of their reservation, how far ago, how long ago the reservation was made, what is the expected arrival time of a customer, who are in the party, who will be staying, how many adults, children, what kind of meal they pre-selected if they did, which country they're coming from, which market segment this reservation was made through, a travel agent or tour operators, the room type that was reserved, the agent ID whom it was booked through. So number of different things here. So you can examine this, and we'll come back to this description a few times as we are working on our analysis charts and as we're building transformations. Now, looks like the data quality insights report has been built. Let's take a look and see what we see here. First of all, a summary, quick summary of the data set. There are 32 features. Features is another name for columns in the data set. Number of rows 50,000 makes sense. That's what we selected when we were importing. You can see that we have some missing values in some of the columns. The number of valid rows is the opposite from missing. The two add up to 100%. There is quite a bit of duplicate rows. That's good to know. And the breakdown of different feature types: 17 numeric, 11 categorical, no plain text, 1 date time, and a couple of binary fields. Two high priority warnings surfaced right away. Duplicate rows, which we already see 30%, close to 30% of duplicate rows. The certain types of models and algorithms are more sensitive to duplicate rows than others. So depending on the model that you're building, you may choose to eliminate duplicate rows. But this warrants actually a closer inspection. Sometimes what may look like duplicate rows might not actually be duplicate rows. If our data set is as simple as hotel name, date when reservation was made, and type of reservation, you can imagine that on one date, multiple reservations of the same type were made, and unless there is a unique ID differentiating them, that may look like a duplicate rows, but in fact, each represents a unique reservation. So this warrants investigation. Target leakage. What is a target leakage? Is, as it explains here, that it actually tells us that the reservation status column predicts the target extremely well on its own, which, if you think about it, makes sense. It looks like the database had two columns that were indicating that a reservation was canceled. The flag is canceled, the column is canceled, 0, no, 1, yes. And reservation status could be pending, could be in process or booking or canceled. And so if it's canceled and the column is canceled, so these two columns are kind of redundant. If we're going to try to build a model and we keep the reservation status column in our training data, the model will latch onto this particular column, will build the perfect model. But then in real life, in real situation, when we're trying to predict whether a hotel booking will be canceled or not, we're not going to have status ahead of time. And so this is what's called target leakage. When we are dealing in our training data set, we are dealing with data that actually will not be available in real life. So these are examples of duplicate rows, a good snapshot to examine. For those, if you have domain knowledge of this data set, you can kind of make a judgment call here whether or not these are indeed duplicates. Some anomalous samples are being bubbled up as well. In order to identify anomalous rows, Data Wrangler uses isolation forest algorithm. Again, it does take someone who is familiar with data to actually look and confirm and validate if these are indeed anomalous samples or not. But it's good to know that there is a flag that can bring your attention to it. A quick analysis of a target column. we can see that it is our target column is canceled or not. 1 means canceled. 32% of records are in that class, and 68% of non-canceled. So unbalanced data set, but it's not too bad. We can work with this for sure. Next, Data Wrangler attempts to build a quick model using XGBoost algorithm, splitting the data set quickly into training and validation. But as you can see, we have a perfect model here. The accuracy was perfect. The F1 scores were perfect. Recall precision. Well, now we know why, right? Because we did have a target leakage. The model just used that one column that was predicting the target variable perfectly. So not super helpful confusion matrix either. Let's see. Feature summary is an interesting statistics. This part shows prediction power of different features. And obviously, you'll notice reservation status has a perfect prediction power, but we're going to eliminate it from our training data set. The rest of the features sort of have pretty nice, even more or less, normally distributed spread for their predicting powers. Looks like interesting. Agent, lead time. Yeah, I would expect that. How far in advance? Country, I guess some of the countries cancel more than others. Average daily rate, I could see that fluctuating and impacting folks canceling, rebooking different hotels, market segments, things like that. And it's just another way of representing that same data here. Target leakage, we knew that. Let's see, let's take a look at some of these now. For each and every feature, now we have this kind of breakdown. I'm going to scroll down a little bit to look at this one. This one is a good one to look into, to dig into. Let me see if I can make it bigger. Yeah. So lead time feature. So you have two charts here, a histogram on the bottom and this chart at the top, and then they are aligned with one another. So the way you read this histogram is you can see the number 25 here, and that the first bar shows that 34% of records in our data set are bookings that were made within 25 days of the check-in time. So relatively, folks are booking their travels 2, 3, 4 weeks ahead, no more than a month out. And what you see at the top here, it says the target label 1 is canceled, 16%. So if we just were to focus on these bookings that are 4 weeks out or less, 16% of them end up being canceled. If we go months out, slightly more than a month out, it's we have 13% of records in our data set are more than 1 month out, a week or two. 35% rate of cancellation for those. And as you go further out, unsurprisingly, cancellation chances grow. So like if someone booked more than a year out, there is a 74% chance that, well, no, I shouldn't be saying that. 75% of records in our training data set that were booked with more than 1 year of lead time have cancellation label set to yes, they ended up being canceled. So you get this kind of charts for, oh, that's interesting, for the countries, different countries. This PRT, Portugal probably, 45% cancellation rate. That's interesting. So you have these kind of charts for each and every feature, so you can examine your data set closely. You'll notice there is another warning that pops up occasionally. Rare classes, for instance, in this case, it says Italy, China, Netherlands, Belgium, very rare. And that it kind of says if you want to consolidate those into one class, maybe called other, to just reduce variance for that particular feature, you can do so. So this is our quick view into the data set. I'm going to click here again in the upper left corner. I'm going to click on the data flow, come back here. You'll see a little chart sign. That means we added an analysis. Let's take a quick look at a couple of more and go into transformations. I'm going to click Add Analysis, histogram, just a simple histogram if we were to pick lead time, and click Preview, and it generates a quick histogram of lead time. You can see that, again, majority of folks are booking hotels within 100 days and so on. What else we have here? Maybe a scatter plot. Let's try scatter plot. On the X, we're going to put maybe lead time on the X, and on Y, maybe average daily rate. And click Preview. See what kind of chart we get here. Looks like an outlier here is messing up our scale, but it's okay. We can still see. Yeah, not a clear pattern, but you get the idea. One specific type of analysis I wanted to show is analyzing your input data for bias. Before we even go into building a model, if our data is biased, chances are the model that we're going to train will end up being biased. And the data Wrangler itself does not calculate bias. There is a separate feature in SageMaker that does that. It's a service called Clarify, but data Wrangler interacts with Clarify natively. And there are other places in your data science workflow where you're going to call on Clarify for data bias analysis, for model explainability, and even in production, when your model is already deployed, you still want to monitor for both, for explainability to make sure that feature contributions don't drift, or if they do, that's a signal you need to retrain your model. So let's take a look at that. I'm going to, again, click on the plus, go to Add Analysis, and one of the reports here, Bias Report. So Bias Report obviously needs to know what your target variable is canceled in our case. And it depends on the bias will depend on the type of outcome that you're trying to predict. And so we're going to say, is there a bias towards non-cancellations? Like if we look at all non-cancellations, is there a bias? And also when you're analyzing for bias, you are analyzing an impact of specific feature. So in this case, we're going to say, let's look at, let's see, what was that distribution previous? So maybe, no, I think it was booking changes. So what I dialed in here is this. I want to see if my data set is biased towards keeping your reservation if you previously had booking cancellations. How biased is my data set towards someone who had booking changes? And now, are they more or less likely to cancel? That's what I'm trying to predict, but I want to see if there is bias based on booking changes in me attempting to predict if they will keep the reservation or not. A little bit convoluted, but that's basically what it is. I'll go ahead and click Check for Bias, and this will generate a report which will do that. While we are waiting for it, we can take a look and see. So we are following this workshop, and we are in the exploratory data analysis stage at the moment. Right here, we talked about importing data. We looked at histograms, scatter plots, bias analysis. We touched on target leakage. I'm going to skip through feature correlation and multi-collinearity for the sake of time, but as we're going to start dialing in transformations, because there are columns that that happen to be correlating, and you can see here reservation status had direct correlation with is canceled or not. You can see correlation 1 means let's get 100% correlation. Few more columns correlate with one another. Arrival date month, arrival date week number, 99%, date week number, date months, reservation status, and arrival reservation status date. So basically what this tells me is that a lot of these columns are redundant. So I'm actually going to drop some of them during our transformations. So the bias report has finished. A couple of things it reports so far on the data. Going by the booking changes. If someone had 3 booking changes, this is the report. And you can examine for different values of that column, 16 booking changes, how much bias is in the data based on that. And you can see the class imbalance variable, difference in positive proportion in labels, and Jensen-Shannon divergence analysis. So these are just 3 metrics that allow you to understand your data bias. On the data level, there is also, and it's kind of outside the scope of Data Wrangler, but there are ways to do further bias analysis on the model. And if we get a chance, we'll look at explainability later as well. But for now, I'll go back to data flow. And let's say we completed our exploratory data analysis. And next, we would like to actually start making transformations to our data. How do we do that? So we're going to click this plus sign and go into Add Transform this time. We're back to that same menu where we already have 2 transformations. And I guess first thing first, let's drop some of those redundant columns that we identified in the multi-collinearity analysis. So I'm going to click Add step. I'm going to select Manage Columns, drop column. And what you can do here is you can just start typing in the column names and they'll appear. So days and waiting list, I'm going to drop. Hotel, I'm going to drop. And I'm just following the guide, the Data Wrangler Lab guide, which as you follow, you'll see the list of columns that we're dropping in there and explanations why, but mostly is because of that multi-collinearity analysis. About date months. And some of these we just not interested in. Maybe if we having the domain knowledge, you might decide that I know that these features don't carry predictive power, so I want to get rid of them. Arrival date, 8 months. All right. So these are the columns that I'm going to drop. I'm going to click Preview, and now I can kind of scroll to see, and I will notice that you will notice that there is slightly lesser number of columns in our data set. And to finalize this transformation, you click Add. And now we have another transformation step that reads drop columns, and we're dropping them. Now, you remember that we, in the overall overview of our data set, one of the warnings was that we had tons of duplicate data. Let's say we do know for sure that we don't want any duplicates in our data set. Let's get rid of them. I'm going to click Add Step and look for Manage Rows here. And one of the options is Drop Duplicates. There is nothing else I need to say. Preview, Add. All right.
We got rid of the redundant columns. We dropped the duplicate records. I think there were missing values in some of the features. We didn't. I didn't drill deeper into which columns had them, but if you follow the lab guide, it explains that one of the columns called children, if there were no children on a certain reservation, sometimes it said 0 and other times it just didn't have a value. So let's go ahead and take care of that. We're going to choose handle missing. And you can see there are different ways to handle missing values. We can run an imputation. We can add an indicator that something is missing. We can drop missing records that have missing values. In this case, we'll do fill missing. The column was, I believe, children. And we're just going to fill. If there is a missing value in children, we'll just fill it with 0. Preview and add. All right. We took care of missing values. Now, if we are building certain types of models, certain algorithms can be sensitive to features that are not normalized, that are not scaled. And so it is helpful often to actually scale your numerical features. And that's what we're going to do here. And as you probably guessed, there is an option for that. So we're going to go in and look for, let's see, process numeric. And we're going to choose scale values. That's the only option. The options here: standard scalar, robust scalar, min-max scalar, and we're going to do min-max scalar, and we'll use 0 to 1 boundaries. And let's dial in the columns that we want to actually scale. There's quite a few, so we're going to do lead time. We'll scale lead time. Stays in weekend nights, stays in weeknights, is repeated guest. Again, I'm going by the walkthrough guide. Previous cancellations, previous not canceled. Booking changes, average daily rate, ADR, total of special requests, and required car parking spaces. I will use the 0 to 1 scaling, hit preview. Quite a few columns for it to transform. And as it's working its way, yeah, here you go. So you can already see a lot of floating point values. And one thing that stands out is we have quite a few categorical values. So we should do something about that. Let's add a step and look into encode categorical feature. You can do an ordinal encoding, similarity encoding, or one-hot encoding. And we'll do one-hot encoding in this example. Let's see, some of the columns is going to be meal. One is full board or bed and breakfast type. Is repeated guest. Market segment was a categorical. Assigned room type. One hot encode deposit type, and customer type. So I think that worked. Customer type. So let's see what are the options. If there's an invalid entry, let's skip it.
And do we want to hot encode as a vector? No, we'll actually create columns, separate columns. So let's preview and see what that does to our data set. All right. Now we should see a lot less categorical. So there is still country, distribution channel, but company is predominantly empty. Reservation status. Did I miss reservation status? Yeah. Oh, I should have dropped it. We knew this was a target leakage column. So let's do that. I'm going to add. I'm going to go ahead and go to manage columns, and I will drop columns reservation status. I will drop country, and what was the other one? Distribution channel. I'll drop distribution channel. Not really interested in that. Company, yeah, let's drop company. It's quite empty, and I think we should be in good shape after that. Preview. This actually makes our data set. Agent looks like a categorical value, even though it's numeric. But this makes our data set looks quite ready for consumption by a very simple logistic regression algorithm. So I'm going to click add, and maybe one more step. If you remember, when we were trying to plot lead time against average daily rate, there was an outlier. So maybe we could do something like handle outliers. Let's see, handle missing, handle outliers, and the columns that we want to touch, I'll go by the guide, are going to be lead time. Lead time stays in weekends, stays in weeknights, is repeated guest. That one is one hot encoded. We don't have to. So yeah, that's enough. Fix method. We're going to clip them. Preview. And add. And so this concludes our transformation recipe authoring time. We have our transformations dialed in on the right-hand side. If I go back to this diagram, you can see that we have 7 steps. And where do we go from here? We've done data exploratory analysis. We've dialed in all the transformation steps. So now we have a couple of choices. We can actually export our data from the memory, this data set that we have right now, not export, sync it into either S3 storage or into SageMaker feature store. And it could be useful if your entire data set was ingested into this instance of data Wrangler, and it's a one time of effort, and you just needed to transform data and take it elsewhere and play with it, experiment with it. You have no intentions of doing it again or in a repeatable manner. So you could just use this option. But what we are going to do instead is we will export this recipe and orchestration code so we could reuse it elsewhere. So we could deploy this data transformation pipeline in production or in another environment where it will run on a schedule or in some sort of event-driven manner. And there are a number of options here. I'll do the Amazon S3 option right now. It'll generate an orchestration code which will initiate a data processing job, and you can then reuse that notebook or take that code, put it elsewhere. Another option, if you are practicing MLOps, would be to instead generate SageMaker pipeline step. This kind of falls outside the scope of this workshop, but there are best practices on how to build SageMaker pipelines, which encapsulate not only data pre-processing, but also model training, bias analysis, explainability analysis, model deployments. So that would be useful if you were to integrate this process into a pipeline. But for now, let's go with the simpler option, a data wrangler job, a processing job, which we can run using this orchestration code on demand. So I'll click that. And what you see is that you are taken to a notebook, a Jupyter notebook that was just created for you. I'll hop back here for a second and show you one more time what's all the moving parts that are at play right now. This is us, this is UI, we have our data wrangler instance. This is where we cooked up our recipe and did all the transformations and exploratory data analysis. And now it generated a notebook for us, a Jupyter notebook. And another instance, you saw it already, it was pre-warmed for us, started, is now powering this Jupyter notebook. So we can actually now step through this notebook right now, which we're going to do in a minute. We're going to go through these steps. And at some point in this notebook, we will actually initiate data pre-processing job. And that data pre-processing job will actually start the pre-processing cluster, which will then ingest the entire data set from S3, all the 120K rows. It will use the recipe that we created, and it'll produce the results back to S3. So let's go back and step through it. So I am going to go ahead and start executing this. In fact, I'm going to execute these steps real quick, and then I'll come back and talk to them while the job is running, so we could then observe the results. So I stepped through this notebook real quick, but let me explain what's happening. The first cell of the notebook is a boilerplate code that you probably have in every notebook that you write yourself. It's just identifying which S3 bucket will be used for data storage and maintaining some basic variables. This second cell right here, it defines subfolders in the bucket, and it begins to define our processing job parameters. In this particular case, we are spelling out the location of the output file in our processing job. You can skip that. It's at this point it's not relevant to us, but destination S3 output path is important. This is where our transformed data will be stored, and we're going to see that later on in the output. In fact, I think it's produced right here. It's showing this is where our transformed data will land in S3. Next, the flow file that we created here in Data Wrangler. Let me expand this hotels.flow. In fact, let's see if we can take a peek inside this hotels.flow. If I was to open it with an editor, you can see that this file is actually human readable. It spells out the steps, recipe steps that processing job will take in order to transform our data. You can see that the CSV file is referenced here. Then SageMaker Spark job will do the inference and casting of the fields, and these are the fields name on the data set. And the next step, visualization, we built one of the visuals. The pre-processing job won't really build the visualization. But as you keep scrolling, there will be transformation steps for dropping columns, for imputing values and things like that. So everything that we've done as we crafted our recipe, it's all been captured here in this flow file. So going back here, this flow file now needs to be uploaded to S3 because data processing job, when it runs, it will expect that recipe to be in S3. And that's exactly what's happening here. We are uploading the flow file to S3. Let's see what else. Loading flow files from current notebook, data Wrangler flow. This is where it gets placed. Next, we are defining the inputs for the processing job. When it runs, where will it take the inputs from? And now these are definitions of the actual job itself, the rather middleware that will be used to run this job. First of all, the container for data Wrangler processing job is referenced here, SageMaker data Wrangler container. The URI, where to grab it from, which includes the exact version. The instance count, how many parallel instances will be spun up to actually crunch through our data. The type of the instance that will be used in that cluster. The size of the EBS volume that will be attached. And then the output content type. And finally, the creation of the job. We define the processor. Those of you who have worked in Amazon SageMaker already, the concept of processors and estimators is familiar to you. If you've never worked in SageMaker before, this might look new to you, but if you go through the SageMaker SDK, if you look at SageMaker SDK on how to start training jobs or processing jobs, you'll notice the pattern is quite similar. You define a processor, whether it's a training estimator or a script processor, and then you actually either call fit on training job or you call a run method to run a processing job. And that's what's happening here. We populated all these parameters already, the instance count, instance types, volume size, all that. And this line right here actually initiates the job run. And you can see the output that data Wrangler flow processing job was started. If I was to go back to my SageMaker console, I should be able to see that processing job and how it's running. So here under processing jobs, you can see that it's been running for 5 minutes. And in fact, let's go inside it, and it's in progress right now. And once it's finished, we should be able to find the output right here. Our data set will be transformed and sent to this output right here. Now, once the job finishes, we can examine the location of the data file. We can take a look inside and see what transformed data looks like. And optionally here, you can actually proceed with the training of a model. Again, this entire notebook was automatically generated by data Wrangler based on the selections and the choices that we made, the types of transformations we dialed, the type of model that we selected that we were going to build. And so in this case, it chose to run the XGBoost, to train XGBoost model. And you can see it has some definitions for the job. Here's it kicks off the training. There are ways to actually initiate training directly from data Wrangler. As I mentioned earlier, there is a menu item here that says train model. And if you come here, you can train the model from here. This is somewhat, I anything that you do here in Data Wrangler might actually be somewhat redundant if you're going to end up training a model using Autopilot. The reason I say that is because SageMaker Autopilot has its own data preprocessing pipelines. So you don't necessarily have to do all the transformations by hand. If you want to use Autopilot, you can just import data set into Data Wrangler, skip exploratory data analysis, skip transformations, come to this menu, select this option, train, click export and train, and this will kick off Autopilot. And Autopilot will inspect and analyze your data. It will come up with a dozen of potential candidate pipelines, pipelines which will include different methods, pre-processing methods, different model types, and then it will execute them all on your behalf, allow the data to be pre-processed, models to be trained, hyperparameters to be optimized. In the end, it will then compare all the models, find the best one, and come back to you and say, hey, based on all these 10 different pipelines and all these pre-processing techniques we've tried and all these hyperparameters we've explored, this was the best performing model. It came out of this pipeline, which used this kind of transformations. You can still pre-process data for it if you'd like, but really there is no need to do that. Let's see if our job finished here or not. I'm going to click refresh. And looks like the job has completed. So let's go look at the output that we produced. It's going to be in the US East 1 bucket, export flow output. So I'm here, export flow output, and default CSV file. I'm going to use the same method, just query S3 with S3 select. I'll grab top, 10 lines from the file. Run, and see what comes up. And this is our pre-processed data. You can see that the values, there are no categorical values anymore. All the most of the numerical values have been normalized. You can see our one-hot encodings here. So that's the data set, and that is the output of our job. So where do you go from here? The couple of takeaways that I want to re-emphasize one more time is that Data Wrangler is about authoring recipes. While you can bring in data and do interactive transformations and then save it, it's definitely available and possible. The main power of Data Wrangler is the fact that you could just operate on a sample data, come up with a recipe, and then Data Wrangler will generate orchestration code for you to apply that recipe in any other environment, in production, staging, pre-staging, in a repeatable manner. And you can version control the code that is being produced by Data Wrangler. You can customize it. You've seen the recipe file that it can be manipulated with as well. So it is possible to create a rather generic recipe here and then have additional logic manipulating with recipes. You can use orchestration code as a starting point to create more complex pipelines, to create more, to integrate it maybe in a higher layer orchestration platform or application, integrated with upstream applications. And you can add more logic to kick off downstream applications once the transformations are done. And remember that the processing jobs that execute actually can run in a parallel mode, and you can have more than one instance, and which does not limit you to the with regards to data size that you have sitting in your data repository. I think that's all I wanted to cover. Another look at the flow file. You can see here how each and every transformation results in certain XML structure, which really refers to Spark libraries that the data pre-processing container implements. I'm not going to spend time on security. This slide is available to you in the workshop guide as well. Yeah, that's. I think this is it for the lab. This environment will remain open for you. We've gone through most of the data exploratory analysis steps. You can certainly explore those that we haven't had a chance to touch on. You can try experimenting with other transformations as well. And there is another set of features that was recently added to Data Wrangler. Unfortunately, it's hard to cover both tabular data and time series in one workshop, so I chose not to do it. But if you'd like to play with that, there is a whole section dedicated to time series analysis. You will be using New York City yellow cab data set, and that data set has time series type of structure where you'll be trying to predict number of pickups based on 1 month or a few months worth of data. You'll look a few weeks out and try to predict volumes of pickups by the taxi cabs. So there are certain transformations that you'll find in Data Wrangler that are specific to time series. There is an entire section of transformations that are specific for time series, and like things like lag features, rolling windows, resampling of time series aggregations. Those are all very specific things that you would apply to columns with dates and times. So feel free to experiment with that as well. Reach out to us if you have any questions. You know your account teams. If you don't, just contact AWS help, AWS support, and ask to be put in touch with your account teams. Your account teams know how to bring us in, AWS AIML solutions architects, specialists, and we are here to help you with anything that you might need in your projects when it comes to data science, data processing, model training, and deployments. Again, thank you for joining today's webinar, and if we have time, we'll do some Q&A. Thank you.